Hello, hello. Welcome again to FreightWaves TV and the Transmission Show. My name is Sebastian Blanco. Over there is my co-host, Grace Sharkey. Grace, tell me about your day. How's it going so far?
It is going great. It's been a good week, great day. So I have no complaints here. How's your day going?
It's going quite well. It's a little wet and rainy out there, but that doesn't mean it's not a good one inside. And today I'm really excited because this show is focused on the automotive supply chain. We've got a guest today who's basically out there talking about how we really need to rethink the whole thing. So I'm really excited to bring on Dionis Teshler, the CTO and co-founder of GuardKnox. We'll do that in just a minute after I tell you about AIT Worldwide Logistics. When you switch to AIT Worldwide Logistics for automotive shipping, you're partnering with a team of logistics professionals in Asia, Europe, and North America who develop customized supply chain solutions that are just as unique as your business. Whether it's transborder hotshot trucking, express ocean service, or an exclusive air charter, AIT has the expertise, technology, and carrier connections to achieve your production goals every time. Check out their link in the show notes. All right, so as I said, the Dionis Teshler is the CTO and co-founder of GuardKnox, which works in a lot of areas of the automotive industry. I first learned about them at CES about 2 years ago, whenever CES was happening last time. Then they were much more focused on sort of at least the stuff that they were talking to me about. They were much more focused on the online connected car security part, but as Dionis and I were speaking about before the show, it's grown a lot since then. So Dionis, welcome to Transmission. How are you doing today?
I'm great. Thank you, Sebastian. Hi, Grace. It's really a pleasure to be here and looking forward for a great talk.
Yeah, so the reason that we were interested in you is the idea that you wrote about for your company website on a company blog post was really a broad rethink of basically a fundamental rethink of the traditional supply chain. And before we get any further, since I'm guessing not everyone has read that article, can I get your condensed version of what you were trying to say there, and sort of how GuardKnox can play a role? I know for me there was one line that stood out amongst above all others, but I'll let you sort of describe it for the listeners and the viewers.
Yeah, sure. So, in short, what happened basically in the pre-COVID times, far ago, nobody remembers those anymore.
Right.
The automotive industry was a really huge customer of the chip industry, basically the silicon or semiconductor industry. And they were buying a large portion of the computer chips manufactured worldwide. And then when COVID hit and automotive production basically declined rapidly, they stopped buying them. But they didn't think about the fact that one day they will restart buying them. What didn't help them was the fact that other companies started buying more chips because when everybody started working from home, PC sales, laptop sales, webcam sales, lots of devices used for communication started going up in sales in a very rapid pace. And these guys started buying off the computer chips. So when the automotive industry came back from the crisis or started going up again, there wasn't enough computer chips on the market. And then they got stuck. Basically, they had to halt production on some of the ECUs or computers in the vehicle because there wasn't just enough computer chips to buy them. I have to tell you that we were hit partially by something similar, although we started during COVID producing some sample devices. We couldn't buy some of the really simple regular computer chips you would buy just anytime. They weren't available on the market. So we actually had to source them from stocks in other companies. We just had them lying around from other projects and buy them at like 10 times the price just to finish the prototype production. And that was a huge deal in the automotive industry.
So the line that really stood out to me in your post was that you suggested it's time to abandon the just-in-time model that a lot of automotive companies use, where they don't want to store, for example, a bunch of these chips at their factories because they want them delivered right before they go into the vehicle. Can you talk a little bit about how you envision that happening? And that's such a major rethink of how things go that it seems like it would. I don't know. Does it create more problems down the line, or do you envision it working quite well once the switch is made?
So I'm not suggesting that we should go back to basically storing chips and installing them when we need to produce and then having huge stocks. I'm actually suggesting that we rethink the way that we look at the design of the hardware and the software that we're putting in the vehicles. And that means if we have, for instance, a shortage of one particular computer chip, we should have a design which is robust enough so we can easily swap out another similar model and just put it in there and continue manufacturing with it. And that's, for instance, something that is widely used in the mobile device industry, so mobile phones, because of competition. So the guys that assemble Samsung phones or LG phones or Huawei phones basically select almost in real time the chip they actually put on the phone based on the current price of that chip on the market. So you can have one phone produced and a minute later another phone produced with different chips because that minute they think that one of them is cheaper than the other, right? And the other part of this equation is also the software. So maybe instead of saying, okay, we have to have these computers in the car, maybe we can live with one computer less in the car and just utilize the others that we have, which are currently not full in capacity in terms of compute resources. And that would require us to be able to shift very easily software from one to the other. And if we have that capability, yes, maybe in the long run it's a bad thing because somebody put that computer in there to be kind of filled up once the car is going forward. But in this particular moment in time, because we have a shortage or because there is a problem, we can still push out vehicles into the road and maybe fix them later or sell them as a lower end version, but still have them on the road with all the basic capabilities that need to be there.
I really like this because there's this wave of going through all supply chains, not just automotive, of resilience, right? Like I think in the past we've always looked at how am I saving money through shipping? How is my supply chain running in order to be the most cost efficient? And we've hit this like barrier of okay, well, now we need to set ourselves up for this resilience where like you said, when one option is available compared to the other, that we're able to make this switch. Why do you think that what would be difficult for companies to switch to this type of model that you're talking about? What would they need to change in house in order to achieve this? And I guess really, why haven't they dove into this type of action already?
So that's actually a great question, and the answer isn't very simple, but a lot of it comes from history and about the fact that the automotive industry has a lot of legacy behind it, which is obviously a good thing, right? It's been around for some time and it's improved, but when you've been around for so long, you kind of develop certain processes where you've built up your entire value chain, your entire industry, your entire company around them, and then changing those core processes is very hard. And one of those is the traditional supplier value chain, the tier one value chain, tier two, tier three, and OEM, and maybe more tiers afterwards. And in that value chain, the OEM basically comes and says, okay, this is the box I want. These are the features I want in it, and these are the variants I want. And now all the suppliers, all the tier one suppliers compete on the cheapest way to deliver that particular unit. And when doing so, they try to actually make it as limited as possible. Because in their minds, the more you limit it, the cheaper it can get. So the more constraints you have and the less scalability you have, the cheaper you can optimize it to. And then they deliver something which then the OEM needs to upgrade in a couple of years because it's just out of resources or it's obsolete the minute it comes out of the door. And that's one thing. Okay, that's one major factor in these legacy processes. The second major factor is the fact that when the OEM goes to a tier one, they basically go for a supplier of a box as is. And they don't go to a supplier of technology. They go to a supplier which is a manufacturing supplier. Okay, they don't expect the supplier to start thinking about how do you create a versatile ecosystem or how do you enable software to move from one unit to the other, because they don't care about that. The tier ones don't care about that. They care about optimizing the production of their one box. And this is where also we come along and we say that the value of the next generation of automotive needs to come not from manufacturing. Of course, manufacturing is important, but it's kind of the old school economy. It needs to come from technology. It needs to come from creating ecosystems and enabling things to work together better, enabling software to move from one place to the other, enabling a more open environment for companies to provide technologies into, and at the end of the day, to improve the product. And that focus on technology as the value generator, which sounds trivial in the mobile world or the enterprise world or anything in ICT, is really not trivial in automotive. And that's what we try to call the Cybertech tier and the new tier in the value chain that we believe needs to be formed.
So the idea of this Cybertech tier in the supplier network, how would that really integrate? I was looking at the diagram on your blog, and it just sort of shows the Cybertech tier underneath, or sort of in pieces, sort of talking to the way that the system is set up now. But with everything being so compartmentalized, if the automakers are going to their tier ones who then go to their tier twos, how do the Cybertech tier, in your envisioning of how this would work, who do they interact with? Are they interacting with all the players? Are they talking to the OEMs or just the suppliers? Like, how to, in sort of a nuts and bolts way, how would this work?
So as a provider of technology, which is kind of the core of the Cybertech tier, they would obviously have to interact both with the OEM and the relevant tiers. And even today, we see that the OEMs are getting more and more involved into the units that are going into their vehicles because they're becoming more complex. And even the tier twos and tier threes are delivering bigger portions, and they are already involved. So they are acting as kind of the head integrator or the main integrator of the vehicle, but also of some of the units. And this is why interaction with the OEM for technology is obviously a must. Nonetheless, if you have a supplier for a particular control unit, for a particular ECU, and you're integrating your technology into it, you of course need to be in contact with them or with every supplier that at the end of the day uses or depends on that technology. That's why it's kind of vertical integration of the supply chain in that regard, in the sense that you're in touch with many points in the traditional value chain. And this is why we're trying to put it on the picture of the traditional value chain. But the new or the next generation value chain will not look like that. Okay? It will be kind of more as a star or as a circle rather than a chain going one after another. And in the middle of that circle, you will have the OEM or the vehicle integrator as the one that needs to put everything together. But they will have multiple types of suppliers. They would have a supplier for technology, they would have a supplier for design of particular ECUs, they would have a supplier for manufacturing, they would have a supplier for computer chips, and all of those suppliers are part of one big pie, one big circle that needs to work together and complement each other in order to create this one thing called a vehicle. So it will transition from kind of a chain approach into a more holistic circle approach. That's how we believe it's going to evolve.
Are there any car manufacturers or companies that you've seen are starting to look at this new way of adding this technology piece to their supply chain? Is I mean, like off the top of my head, I'm gonna throw out like maybe Tesla or someone like that. But is there anyone that you've seen starting to implement those processes?
Yeah, yeah, for sure. So, for instance, if we look at the European OEMs, they're undergoing a big shift of vertical integration. VW has decided that it's going to open an internal unit for advanced technologies development. It started off only with software development, but now it also transitioned to hardware development and microchip development. That was a very recent announcement by Diess, their CEO. So they're basically centralizing advanced technologies under one unit. And this unit is working with multiple types of suppliers. So it's working with the traditional OEMs, and it's also working directly with companies such as us in order to basically use the best of breed product for all control units that they need. And it doesn't matter if that product is coming from a 100,000 employee company or a 100 employee company. As long as it's a good product and it's the best, and that's what they need for their vehicle, they will then integrate it into the complete architecture. We see that even, and they're not the only supplier, but they're a very good example because they have a lot of PR out on the way that this unit is going to work. And we also see that the tier ones are doing similar ways to mimic this new structure. So you see essentially companies such as ZF that are creating software houses, dedicated software houses, focused on advanced connected technologies, where they want to also work with the best of breed suppliers to then provide the best product to their customers. Uh, we're seeing suppliers such as Continental starting to work with Amazon and AWS, building up a new business unit for connected technologies. You see Bosch trying to do the same by opening a business unit for high performance computing. So it's really across the board. You see it not only even with OEMs.
Another aspect of the sort of this different kind of companies and suppliers working together would be the software code itself. And the thing you mentioned earlier about a way to reduce the number of chips that you might need in a vehicle, at least in situations like what we're facing right now or what the industry is facing right now, would be to offload some of the code to a processor, to a chip that isn't being used as much at that particular moment. How in the way that you're talking to these other suppliers, these other companies, or just reading about it, how difficult is the idea of like who owns the code? Like if an automaker is getting different components from different people, different suppliers, then maybe one company's code is in one module and another company's code is in another. Like how do they interact easily, and not just technologically possible, but also for security reasons, both the company's proprietary information as well as against outside attacks?
Yeah. So that's also a great question, and also the answer isn't very simple. But one thing that I can tell you that something more complicated than technology is IP and proprietary information and legal. That's something that even technology can solve in some in some cases. So the OEMs like to own the code. Not all the time it's possible. So some companies don't agree. But that doesn't mean that the code can't be portable or can't be flexible. Okay, that's why what actually we are proposing with what we call the service-oriented architecture for vehicle software, and we have a whole product line on that. It's kind of middleware. So it's this level of code which is below the apps that are running, but above the operating system, somewhere in the middle, that will essentially enable this portability and flexibility that even if they don't own the code, but they want to move the software from one place to another, as long as it complies to kind of basic rules and interfaces, it will be completely movable and it won't actually care what hardware it's running on and in what environment it's running on. And that goes even a step further into this world where some OEMs are looking at kind of universal hardware. So today you have dedicated ECUs for each functionality, but as we transition towards software, all these functionalities are basically applications. And why not put a couple of big ECUs that will run all those applications? And one step further from that is making those ECUs generic. So the difference between kind of a cheap vehicle and an expensive vehicle will not be that it will have more fancy ECUs, so to speak, but it will have just more of the same, more horsepower, more processing. Just like back in the old days, a cheap car had 100 horsepower and an expensive car had 500 horsepower. So the equivalent in computing would be exactly that. It will be the same horsepower, but more of it.
That seems like it's really good as a way to get the pieces to interact. How good is that? Just in a brief ending here as we get towards the end of our show. How good is that then? This interoperability for consumer safety for their private information as they're driving their car, because as cars get more and more connected, more and more data starts flowing. I'm guessing, given your name and the company's history, that you guys are thinking about this. But can you give us the brief version of how this can be so interactive and sort of generalized to the broader industry, but also very secure for the individual?
Yes, and not only for the individual, for the vehicle. So not only private data, but as you mentioned, exactly safety related data. So there are ways to kind of compartmentalize software in the vehicle and to provide security measures that between compartments make sure that things don't act up and don't attack one another and don't prevent one another from working. So essentially, in a world like we have today, where per ECU you can have dozens of suppliers of software, it's even relevant today because one of these suppliers, even not being malicious, can just have a not very secure piece of code and somebody can exploit that. So what do you do? What do you do when you have so many suppliers and it's so hard to verify? So you basically create infrastructure which compartmentalize the damage. So even if something happens, it's limited in scope and you can enclose it. And that way you at least prevent it from spreading. And then on top of that, you can have advanced measures for access control, for verification of the traffic that's being passed to the vehicle and in between the vehicle components. And also in that, integrate security for private data. Basically, treat private data as its own security class and separate it from the other data, maybe encrypt it, make sure that it doesn't get mixed up with the data that is going out to the public or going out to the OEM in exactly the same way as you would separate safety critical data or security critical data. So privacy is, to us, another class of security related data that we need to protect. And if you have this infrastructure mechanisms for separation and for what's called multi-domain control or multi-domain security, where you make sure that what passes from one domain to another is safe and secure, then you can also protect privacy, you can protect safety, you can protect security, you can make sure that everything is operating properly.
Well, that's given us a lot to think about. I think a lot of times one of the benefits of talking about the supply chain is you get to see into the future a little bit because we know the industry moves so slowly, things take so much time to ramp up. So this is a lot to process. But it's been excellent speaking with you. Thank you so much for joining us today on Transmission. Dionis Teshler, CTO and co-founder of GuardKnox. Thank you very much.
Thank you very much, Grace and Sebastian.